Hello. Day 14 is day 14. Let's get into it. Hello again. I am only 2 days behind, which I feel good about, given that I'm doing this in such a weird way. Let's take a look at what day 14 has in store for us. If I kick over to the monitor here. Also, I guess I've run out of Mario 64 Tame Impala, so we'll get some other music going. Let's see here. Day 14, Regolith Reservoir. Interesting. The distress signal leads you to a giant waterfall. Actually, hang on. The signal seems like it's coming from the waterfall itself, and that doesn't make any sense. However, you do notice a little path that leads behind the waterfall. Correction. The distress signal leads you behind a giant waterfall. There seems to be a large cave system here, and the signal definitely leads further inside. As you begin to make your way deeper underground, you feel the ground rumble for a moment. Sand begins pouring into the cave. If you don't quickly figure out where the sand is going, you could quickly become trapped. Fortunately, your familiarity with analyzing the path of falling material will come in handy here. You scan a two-dimensional vertical slice of the cave above you, your puzzle input, and discover that it is mostly air with structures made of rock. Your scan traces the path of each solid rock structure. Sorry, I was testing audio there. Your scan traces the path of each solid rock structure and reports the XY coordinates that form the shape of the path, where X represents distance to the right and Y represents distance down. Each path appears as a single line of text in your scan. After the first point of each path, each point indicates the end of a straight horizontal or vertical line to be drawn from the previous point. Okay. This scan means that there are two paths of rock. So this example here. The first path consists of two straight lines, and the second consists of three. So we've got a line of rock from 498.4 through 498.6, and another line of rock from 498.6 through 499.6. Okay. Sand is pouring into the cave from point 500, 0. Drawing rock as hashtags, air as dots, and the source of the sand as plus, this becomes this. Okay, so, right, and so this makes sense. We've got, so this is 494, 4, 5, 6, 7, 8. So this is the 498.4 through 498.6, and then 498.6 through 496.6. 503 here is like, yeah, so then we've got one that goes from here to here, and then from here down to here, and then from here over to here. Yeah, okay, that input makes sense. And it's pouring in from right here. Sand is produced 1 unit at a time, and the next unit of sand is not produced until the previous unit of sand comes to rest. A unit of sand is large enough to fill one tile of air in your scan. A unit of sand always falls down one step, if possible. If the tile immediately below is blocked by rock or sand, the unit of sand attempts to move diagonally one step down and to the left. If that tile is blocked, the unit of sand attempts to instead move diagonally one step down and to the right, and sand keeps moving as long as it is able to do so. At each step trying to move down, then down left, then down right. If all three possible destinations are blocked, the unit of sand comes to rest and no longer moves, at which point the next unit of sand is created back at the source. So, the first unit of sand lands right here because it hits there and can't move down in any direction. The next one falls onto the left of that, and then it'll fall onto the right, and then... How does one get over here? Hold on, wait, it's falling down this column here. So it falls down this column. That one makes sense, and then this one makes sense, and then the next one would go here. then the next one would land here and not be able to move down. I don't understand that. Oh, right. So the path that it follows, if I draw this diagram for myself in a text editor here. What am I looking at? So if let's see, I have some stuff from work that I don't need to keep around anymore. So we start out like this, right? Then the first one falls from above and we get that piece of sand there. The next one lands here and falls down left to here. The next one falls here and falls down right to here. The next one falls here and stops. The next one goes here, falls down left to here, falls down left to there. And that's the way that it works. Okay, that's doable. That's doable. So I think that what I should do is I can make it dynamically produce a grid, and then I can build a simple cellular automaton, basically, that where I can have sort of a grid of cells and then have sand that sort of like falls in the requisite directions. I think that actually won't be too bad to do, but I'm sure I'll be proven wrong. So that's what we have to work with. The overall question is, how many units of sand come to rest before sand flows into the abyss below? This all actually seems quite doable. So I'm gonna grab a few screenshots like I usually do. Why does Windows have that delay? It's so odd. What's so hard about taking a screenshot? I hit Control S like several seconds ago. Is it gonna show me the dialogue here? No, it apparently ate that input entirely. Escape key doesn't work. Great behaviors all around. This is what it looks like. Save that. And the ultimate question is, how many units of sand come to rest before sand starts flowing into the abyss below? So, with that, I think we can hop into dreams. So, let's hop over to dreams and get today going. Let's get ourselves a new scene. So, there's a couple steps to this. Oh, I need to get my problem up on screen. Shuffle some things around. I'm gonna be cute and swap this image for another one that I can sort of put comfortably behind the old webcam. Okay. That'll do. So let's get this going. Also, I kind of feel like having the right ambiance right from the start this time. So let's search for cave. Let's see what we've got to work with here. It's kind of bland. Let's see how this one looks. It's not very snowy, but I can deal with that. That's annoying that I can't seem to like everything I'm hovering on. I can't get an accurate picture of the colors because it wants to be washed out like this. Okay, am I? Let's try a different one. Waterfall cave. That would be thematically appropriate to the problem, but not quite what I'm going for. Okay, so this is exactly the same as the last one, except that it's also got some structure back here. Demon cave here. What? Why has it blurred the camera? I don't understand. Why have you done this? Where's this? Where's the camera node that's making everything blurry, huh? I really just kind of wanted the, wow, this is an impressive sculpt. I just didn't want it to be blurry. Wow, this is an extremely impressive sculpt. Oh, it's got sound and everything? Alright, this is the one I'm using. This is so much cooler than any sort of default bricky sort of thing that I could do here. So, let's see. Where is a sufficient abyss in this cave? This looks abyssal. Man, people make such cool stuff in Dreams. It's amazing. Such cool stuff. Alright, I'm gonna have it be that stuff just falls into the water, I think. Because overall, I think that this is easily, you know, this is where they had set up the camera and stuff, and this is easily the most picturesque part of the cave. So I can set up my little problem right about here. Here, let me move the whole thing up a little bit just so that we're above that grid. Let's see, I'm gonna get rid of that fog. I'm also gonna get rid of, like, basically everything here. Let's see, this is just sound, right? I'll keep the sound. The sound is kind of cool. Obviously the lighting is excellent here. I wouldn't dare do anything about that. We'll keep the low fog there. And we'll, I guess, set up a new... Well, we won't worry about a new camera just yet. Well, what the heck, I'll add a camera. Because it's going to be something like this. And it'll be super cool. But we actually do have to make a program somewhere in this mess. Let's start by I guess sort of defining the grid that everything is going to be on. In fact, let me show the grid here. Actually, maybe I should grab the camera and this and oh. Okay, I had accidentally scoped that into the whole cave group. I didn't mean to do that, because what I want to do is move this down to kind of the floor, because I want to actually see the floor here, and I want to have the whole thing rotated so that I can work on grid lines. Everything will be easier if I can. I could make it completely like position independent, but I don't want to. So maybe this will be fine. A little bit of a jaunty perspective on it would probably be cool. But that said, we still probably need something to mark the origin. So let's drop a tag into the world here. You get on the ground. There we go. There we go. Perfect. You will be aligned to the grid, as will you. Okay. You define the base of the whole thing. Well, actually, I'll put it like here. And then we'll go by units of 1 because, well, let's see. We might have to go by units of smaller than that. Let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 across, which would be like 4, 8, 10. Yeah, we're gonna like put it here and step by units of 0.5. So that'll be the sort of foundation of our coordinate space here, I guess. Let's then add the microchip that's going to contain all the good stuff. All that delightful code that we love so much. I don't know. Just because I can, I am going to get a node in here already that represents, come on, this tag's position, because we're just going to need the position component of that. At some point, but we won't worry about it for now. Let's start by inputting our program, which this time is mercifully short, although getting everything to kind of draw out correctly still might not be that easy. So let's start by dropping in a microchip that we can use to define our input in the form of these lines, the 498.4, 498.6, etc., which, I mean, really cleanly maps to, I guess we're going to have a couple levels of iteration here. We're going to have first the current pair. We got to output that. But we're also going to need the number of paths as well as the number of elements in the current path. So in this case, we're going to have 2 paths, but the number of elements in each path I'll call them points. They're points along the path. That'll vary. The current point will be this. Now, the way that we're going to do each of those points is going to be with a 2-wire combiner, which is going to have a value slider on it, representing the numbers. Very straightforward. Now, why we're doing this with such large numbers, I don't know, but I'm just going to, for the sake of this problem, I'm going to have some stuff that represents the min and max, and I can do that math pretty trivially. So this one is going to go from, let's see, I guess from 503 to 494. Oh, for crying out loud. And the other one is going to go from 0 through 9. Those are going to wire into there, and that'll form one pair. So the first one is 498, 4, and onward. So we'll copy that down. Perfect, as always. Okay, so then it's 498, 6, and then 496, 6. That is gonna wire up. Well, let's see here. I should really start by putting all of these on a microchip together. And then that microchip can borrow this node here, point. It can also have all the selector shenanigans in here. Very important, of course. Power that one, and power this one. This is how I iterate, if you haven't seen it before. We'll put in a node that represents the current point. Which we wire into the active port on the selector. And finally, we need one that is number of points, which we can wire up from the number of ports thing on this selector. So that does that just fine. I can hook up num points to there and point to there. I can hook up current point to this. And also, I'm gonna need to do something a little funky, which I guess is like, I'm gonna have one that's just called active, because normally I would power, oh no, actually it doesn't matter, does it? There's this annoying problem of, like, when I power down one of these selectors, oh, I can power down the output. That's what I'll do. When I power down the selector, then this node doesn't get any signal, and so then I don't have an accurate count of how many things I'm iterating through. But what I can do is power this output node instead, and then I won't have any issues. So call this active And that will just go straight into this node's power. Okay. So there, that represents a single path. Now we can create one more path right here, which just has an extra thing in it. Just copy that down, hook it all up, and then change all the numbers on this path. That should really be it, aside from, you know, the numbers. So 503.4 to 502.4 to 502.9 to 494.9. That's all there is to it. That gets wired up to there, and that to there, just like before. And then we'll have the outermost selector that takes us through all the paths. Now that's going to wire into the active ports down here. So that's current point, but also we need current path. Hook that up just like we did before. And we'll hook up the num ports thing to that. And just like that, we have our iterator through those paths. Mercifully small amount of data compared to some of the stuff that I've been doing. So we should be able to iterate through that just fine. I can grab my iterator buddies. Or they're not there, they are thing I made, so they're here. So we're gonna need a couple iterators. We're going to need one to take us through the paths, so that's gonna be the one that takes num paths, and another to take us through the points per path, and so that's gonna be this one here. We want the index of this one to be the current path and the index of this one to be the current point. When we step this one to the next one, we want to reset this iterator to whatever value is coming in here next. We'll figure out the actual stepping to next in a bit, but that should basically do it for this basic iterator setup. As per usual, I'm going to grab switches that I can use to manually step from one path to the next or one point to the next. And then this here will have our point coming out. Just for the sake of visualization and debugging, I am going to hook up some number sliders to that just to be able to preview it. We're going to therefore just toggle them into this state. All right. So that way we can always just see which step we're on as we're iterating, which should be nice. Let me just quick save this. I don't want to get off track here. So this is called Advent of Code 2022. Day 14, Regolith, which I really doubt is in their dictionary. What was it? Regolith Ruckus? What was it? Hang on. Regolith Reservoir. I think Regolith Ruckus is a better name. They also don't have Reservoir in there. No, they do. It's just an unusual word. I'm not surprised that they don't have it pop up right away. Okay. What we need to do here is, well, to be honest, I think I might already be sort of on step 2, and I need to step back and do step 1. So here's how I'm imagining this will go. Since we're going to build like a cellular automaton, where basically like the sand is doing these like discrete steps, what I want to do is make a grid of an actual grid in the dreams world of all of these spaces that we want to do. And then those spaces can be of different types, so they can be air or stone. And then I need to have that whole grid ready. And then I can have this code go through and just change the types of a bunch of them. So there are pre-existing spaces that will be turned into... Oh, there's actually no reason to do that. There's no reason for air spaces to do that. I can just spawn rock spaces and that's fine. Just rock objects on the grid. And I think that that will actually work out okay. So what this means is that I do have to make rock objects. I also probably need to grab my gridder, which is a thing that I can use to spawn things in a grid. Although maybe that doesn't matter. It probably doesn't actually, because I'm going to have stuff in this already, like a common bit of logic that can convert from program coordinates into Dreams World coordinates. So yeah, I'm not gonna bother with my gridder thinger. Let's go through this then. If we've got the current pair, we're gonna need to look at the index that we're on here and do something a little bit different with it. Basically, if this is 0, then we need to like go to a certain point but not spawn anything. Well, maybe we'll spawn the first one, but in any case, if this equals 0, then we need to spawn like the first rock in a sequence. Otherwise, we're going to actually iterate through a bunch of stuff. So I guess we're probably going to need one more iterator, which we'll figure out what to do with that in a second. Let's start by just spawning one thing. Right when the program starts, spawn a thing at these coordinates. Now those coordinates are going to be determined by something here. Some common logic for like X and Y and, you know, all that jazz. So we need a node coming in for the coordinates. That'll be a good old-fashioned 2-wire pair, which, for the sake of wiring, for ease of wiring, I can do this to make sure that Dreams understands that the type of this wire is in fact a 2-wire, a 2-value fat wire. What we can do then, what we want to do is actually return another, I guess if we want it to return a scene space transform, then that's going to be combined into a 3 number, so a scene space position. So that is what we're ultimately working to output. Now the way that we'll do that is through some pretty simple conversion, but we need a few constants up top, which I can sort of grab, I can grab from here, I guess. So this is going to be the min, I guess I can name it as such. This is the min x coordinate that we have in our problem, which I'm hard coding for the sake of making this work. The max doesn't really matter. We also need the max y because we're sort of constructing this, I don't know, there's this weird, like, I'm taking the position of the bottom left corner because I want to make sure that they fall into the water in a way I like. But that means that we have to sort of flip the problem upside down, I guess, so to speak. So 9 is our max y. So there, those are the sort of two constants that we have in here. I guess we also need something for the scale, like the space between things on the grid, which I believe I said I was going to do 0.5. So boy, I just absolutely adore how you can't change that when the max is something else. It's so good. So 0.5 is our actual spacing between things. Besides that, I guess there's one more node that I need, which is for the origin, which is the tag that I placed in the world down there, which will always be the bottom left of our graph. So that one will always be wired into there. So what I can now do is for the x coordinate, I will take our x coordinate and subtract our minimum x coordinate to get our offset horizontally. I can then multiply it by, not max y, spacing. Call it spacing. So that way, if it's 494, it'll be at position like origin plus 0, then origin plus 0.5, 1, 1.52, 2.53 across the grid. That then, if that's sort of our x offset, that's one component of it. We need to add that. Let's see, actually, I can do it like this. We're going to use that as our x value. For our y value, because y is the vertical axis in Dreams, we want to do like 9 minus our coordinate in order to flip it upside down so that an input value of 0 goes to the top, and an input value of 0 goes to the bottom at 9. So we will put another subtraction in here and do 9 minus this, and then also times 0.5. And then that is going to go into there. And then that is all going to be added together with this, because you can use the addition node on fat wires like this. So we can grab our plus and say this plus this, and that's our result. Hooray. can consolidate this a little bit. Okay, that should do. So this is, we'll just call it like 2 world, I guess, because we'll take game coordinates and put them into the world. So I guess then I can just well, let's see. I'm getting a little bit ahead of myself here. I need to actually grab the, like, some sort of rock structure. If I make you more squarular. I don't have a good way of doing that. I mean, I could shrink this down to the right size and use it. Right? Like, you know, put it on the grid and... I mean, that wouldn't be too bad. The problem is that it's not very tall. And I kind of wanted it to be roughly the size of, you know, I kind of want it to be square, which, I mean, I admit is a strange request. It's not such a strange request. Look at this. Ha! Perfect. This looks sort of blocky enough to serve as my basic rock. In fact, I could spawn this at a random orientation for a little visual variety. That'd be neat. I might try that. But I need to make sure that this is exactly the right scale. Let me start by... I'm just gonna go into sculpt mode myself and just sort of create something with exactly the scale I want, just for starters. Let's see, I think this is the right scale already. It is. So. There. So this is the size I'm going for here. That's your aligned to grid. I beg to differ. That's pretty good. I mean, that's close enough that I don't think anyone would bat an eye. I guess the question, though, is when I emit such a thing, where will the center of it be? We'll see. It might not have really mattered how I moved that. Let's start by adding an emitter, since we know that we're going to be spawning these things. You will be emitting this. Okay, yeah, because I don't really have control over what it considers the center of the object to be, so it's probably kind of whatever. I can fudge it in code a little bit if I have to. I guess a thing that I could do is to have like, okay, here's what I'm gonna do. Because it is actually important to me that this thing is spawned on grid coordinates, we're actually going to, take this, which is basically lined up with the grid. I guess I can line it up slightly better. And, oh, actually, I'm curious. Never mind, that didn't help anything. Well, this probably still doesn't help me, does it? I was thinking, I've got it. I'll parent it to another block here, but I don't think that helps me. I'm like certain that doesn't help me actually, because it still isn't going to give me a way to adjust what it considers the center point to be. So we will spawn this with no velocity, and there is no maximum on the emitted things. You will emit once when you are powered on, and I will tell you exactly where to do it. Deal? Let me turn on preview invisibility just so that I can, because we are going to need to put some at least tags on these things. We really might only need tags. So for now, let's go back into my old grid mode. Okay, is that on the primary dreams grid? Kind of. I guess now it is. Yeah, I think with that, we are in fact on the dreams grid. So this is a centered rock, even though it doesn't entirely look like it. Like I said, we might be able to fudge it slightly. But for now, this is fine. So that's what it's going to be spawning. Okay. I'm just going to move this up here so that it's more visible. Not that it really matters. So let's go through and spawn just one thing here. If it's equal to 0, we're going to spawn one thing at the given position that I tell you to. We can do rotation later. Oh, the coordinates are this. I do need to pass that in, that's important. So, now I guess we could see exactly what the coordinates are. If I were to split this out. It's not very helpful, I think, that this is like ranged the way it is. So this should probably be like minus 999 to 999. So we've got these two units, two things telling us visually where things are going to go. Now when we spawn that one thing, that's when we want to move on to the next. I should look back, actually. Yesterday's stuff worked really well, and I want to go back and remind myself how exactly I did some things. Specifically, how did I do the step to next? I just had a wholly separate signal here on use that would, in my case, well, okay. I can do this again, just power on, just pulse the signal that steps you around to the next. And do it all with wireless transmitters. Okie doke. Where's the problem? There's the problem. Slurp. So, I guess I don't really have to yet because, like I said, I'm doing it with switches first so that I can kind of just do one at a time. If that's not equal, then, well, let's just see. Does this spawn a thing in a useful place? Nope. Which way is the world oriented here? What is positive X? I get the sinking feeling that no. Why is it spawning over there? I'm gonna just proceed. We're gonna see how it draws it out, and if I need to do some other coordinate shenanigans, and I guess I will, but I kind of am confused. If I hook this up to here instead, and then move this, that is decreasing X. So I was weird and flipped the whole world around by accident. Okay, well, that answers that question. Thankfully, since I'm doing this convenient two-world thing, I can do, I can just negate this. It's annoying, but I don't want to flip the whole world 180 degrees, so. Whoops. Times -1. Yeah, so now we're spawning at what may well be 498.4 if you're looking at the diagram there. Seems plausible. So let's step through the rest of it now. So if that is not true, so that would be like this. Then we're gonna do something a little different. We have to figure out how many steps we're going to do by, I think here's what I can do. It's gonna be a little strange. I need to modify this to output the previous value as well. Oh no, this sucks. No I don't. No I don't, I refuse. I refuse. We're going to instead have a couple variables here that store rock X and last rock Y. Cause ain't no way. These variables are going to get set when we emit any rock at all. What we can do is just take the coordinates from here, yeah, that point, and pass that into a couple variable modifiers. So last rock X, we're gonna set it to whatever try to think how I want to organize this. And it's going to be as simple as this. As simple as that, but also we need to spawn a, or we need to, let's see. We need a microchip to keep this stuff contained because we're going to be using power, so spawn rock. Such that when we power it on, we'll set all that stuff. And the power now is not going to go to there. It's going to go to here. Neat. What we're going to do here then is we are going to figure out how far we need to go based on the current point and the last point. The way that we're going to do this is a little bit interesting, but I think that it'll work well. Because we know we're going only vertically or horizontally, we essentially need to figure out which of the two has sort of a delta on it. The way that I think we can do this is we'll grab last rock X and last rock Y, bring them over here, put them together into a 2-number wire. We can then take this point and subtract one from the other. Which one we're subtracting from the other is irrelevant. This is going to give me a 2-number wire that has one of them set to some value and the other set to 0. I don't know which, and I don't know the sign, but it doesn't matter because I'm going to take the absolute value of this. I think I can do that across an entire 2-wire, and that's fine. And then I can simply do a calculator that takes the maximum of those two. We have to split it. And I think that that will tell me how many things we want to go through. So to give a concrete example of my thinking here, so these are going to be like 498 and 4. Then the next one we're going to do is 498, 6. And so it's going to be 498, 6 minus 498, 4, which is going to result in 0, 2, which I take the absolute value of to keep 0, 2. and then I split it out and I take the maximum, and that's 2, which means that since we have a path of length 2, we need to spawn 2 more rocks. Then we have 498.6 to 496.6. And so that's going to be 496.6 minus 498.6. That'll be negative 2, 0. Absolute value of that to get 2, 0. Take the split them out and take the maximum. 2 again, 2 more rocks to spawn. So I think that all works fine. I kind of want to consolidate some of that down into a microchip just to make my life a little easier. Num rocks in segment. So that is going to be the number of things that we're iterating through. For the time being, since I'm sort of running everything manually, we'll grab this switch to control next as we step through our iteration. And then we can, again, basically just go into when we use this thing, then we power this thing on. So let's try it. So that spawned 1 rock. Now, we pump this one, which then... Okay, no, my problem is that this was already staying powered on, which is not correct. Also, when we step to the next path segment here, this needs to be reset. So I think per my usual logic, all this stuff needs to stay outside outside of any power stuff that we're doing. But the results of this will go into nodes that control power. So basically that would be like, well, that one can go straight across, but no, it can't. I think, let's see, I need a microchip in the middle here that can be powered basically. And I think it's basically just gonna have this. Although it's not really much use if, hold on. I gotta look at something. I have to hop out of my creation and go back and look at yesterday's because there's a weird nuance that I'm forgetting. So this is kind of the core logic, and this is the thing that steps to the next. We only step to the next when we receive, well, no, when we receive the use signal. What is actually changing? This is changing the depths. not as informative as I hoped. But basically in here, I think we need to make the decision about whether we're continuing to the, whether we're doing basically next path, or I guess next segment, or next rock. Yeah, because I think that basically what happens here then is that we put that value out there and this value out here. In both cases, we are going to spawn a rock, but the question is which thing we like increment or something. Which means, let's see, we basically want a couple, let's see, this is where I can pull in one of those AND gates again. That's sort of the like master enable for all of our logic that happens within the iterator. So this can only happen when, let's see, this is the iterator over all paths. I think we only want to use this thing when all three of these iterators are like, yep, you are good to use. And that way, whenever we step one, we will always appropriately step everything. So, this starts out spawning 1. And then I think that because we are attempting to fire on next segment, that would be this. Okay, hold on. That was not right. Spawn that first one. Spawn the next one. They're spacing out more than I wanted them to. Spawn the next one. It's supposed to spawn one more. Then go to the next. Yeah, something's off. Also, this is nonsensical. I mean, we always want to spawn a rock, so really there's no reason to do anything other than this, I think. You can just put a switch on here. That'll just power on as we do stuff. So, what I'm expecting here is... Wait a minute, what am I expecting? What is wrong with me? What is wrong with me? I'm not, in fact, computing new coordinates for anything at all, which is stupid. I'm only spawning things in the corners of the path. So that's incorrect. I think, then, that the... aha. I need to pass in the... I need to pass in and calculate a couple coordinates here. So, besides just the, like... Here, I guess this is index. I'll call it index. I'll give things names. I'm a good programmer. I give things names. Besides that, I'm going to pass in the last coordinates and this coordinates. Because that's what I'm going to use for all that stuff. I guess I'm just going to call it last. That's sufficient. Because last is gonna come in here. This is gonna come in here. And I can do math with this. So, the, we're going to output some coordinates for a rock one way or another. If these are equal, we're literally just going to output... Hold on. The current coordinates. No funny business. How sad that I have to wire up to this every time. Otherwise, we're going to wire up to this. And this is going to be some math where I basically linearly interpolate from here to here, which I can do. I can linearly interpolate in these coordinates, and this is a linear mapping, so I'll get a perfectly reasonable result. Let's see. I have a thing called. Yeah, it is just the position. So we'll copy that out and give that a nice name. Let's see. The math is, it's going to be a lerp. I swear I've already made a lerp. Did I make this? I don't think so. But it's also fine. Yep. It is a lerp. And yeah, it straightforwardly passes all that stuff through, so that's nice. The main thing is actually getting the value of t, which is just going to, I think, be the incoming index divided by the total. It's the segment total here. This is getting messy. Let's move you all down here. Okay. Now we've got a nice obvious lerp. It's not the clearest wiring I've ever had in Dreams, but okay, so that still did the wrong thing. Right, because I wired this up incorrectly. Okay, it's still wrong. Why are you wrong? Let's see, our T is 1 divided by 0. Champion. What? Does absolute value work? Absolute value might not work on fat wires. Let's probe that, shall we? Well, wait a minute. We've got 498 and 4 passing through there. And now what do we have? Let's see. $494 and 0. That's what I expect. Wait. No. Zero and 0. Why though? So despite stepping to the next, I mean, this thing is outputting 0.1. So it should be outputting 498.6. Well, I mean, I can see that. So we should have 498.6 coming in here, and oh, this is also 498.6 for literally no reason. Super cool, super cool. Why are you that way? Why are you that way? Why did you step ahead to that immediately? It's 498 and 4. Then it steps to 498 and 6 because it already tried to spawn the new thing because that powered on like too early. No, that actually makes sense. So it's these variable modifiers that are wrong. That is not what we want to do. I think that we only want to do this when we step to the next. Oh my god. Why are you like this? Why are you like this? So this isn't gonna work either. I've got just an annoying issue here where, like, what I actually want, that's not the last rock, that's the last, like, point. Let's see, I need to modify the variables over here, actually. That's supposed to be the last path segment corner that we visited. Unfortunately, though, when I can actually power this on is a little bit dicey. Well, it's not actually that bad. No, it's not at all. I think that we just want to set the last point here. When this thing goes into its use state, which is distinct from when everything else is stepping. So now we get 498.4. Then I can step that. It still went to 498.6. Because of course it did. Yeah, I wasn't thinking at all. Okay. We're just gonna dupe these right up and double buffer the whole thing. This is current point X now. And current point Y. And what's gonna happen is that this now has to set, like, let's see, index is this. We don't really need the total, do we? We just need the index. So we're going to have variable modifiers for last point and current point. It's going to be a little bit funky how this works, but I think that basically, if we're index 0, then we're going to set these things to the current things and these things to 0. No, we're actually going to set all 4. This is, I didn't expect this to be quite so much of a problem, but I really never know what's going to be problematic, do I? So if the index equals 0, then we are going to power this on and set, or which one are we going to power on? Hey Ninja, it's going okay, just okay. I am struggling to do some stuff that feels basic today for whatever reason. But I'm trying to spawn rocks in this cool cave that I found on the Dreamiverse that will match the structure that you see on the left picture there. Naturally, I'm getting this weird stuff with variable settings. So okay, let me now think this through a little bit again. Basically, on the first index, we're going to set last and current both to the new coordinate value. That's like a hard reset. Otherwise, we're going to do something else, which is to set last to X. Let's see, actually, oh gosh. All the nested microchips. Otherwise, we're going to set these two things differently. I'll put those in a microchip on their own in a second. But basically, we want to transfer current to last. So I need to actually just copy these variable modifiers down, but switch them both to get mode, and then wire them up. As well as set current to our incoming coordinates. We'll see if this works. I am not confident. So this is going to be like update point. Both 498.4. Now, step to the next one, and now they're both 498.6. Why, damn it? Ah, good. Yeah, the elves on the steps was a good time. So this has apparently set current point X to whatever, and that must have taken effect before we set these. A fact which is deeply frustrating to me. Because these are now supposed to differ. They are supposed to be different. This sucks, man. I don't understand why Dreams has to be this way. Like... Let's see. Can I artificially induce a frame delay? I need to first update yeah, it's like I need this to happen on a frame delay. It's like I need to first copy current to last before we update current. And then what we can do is what do we call this? Update last. And if that is sending anything at all, then I'm really just trying to explicitly induce a frame delay. And that will come in here and power these on. $498.4. Then we pump to the next. And now nothing works. Probably because I didn't do anything here, which, you know. So that worked. Sort of. Didn't work. Okay. It worked one time. So when I pump that, there was the one frame delay I desired. Then I power this off, but that thing stayed on, which resulted in current setting to next, but this actually not. No, that doesn't make any sense at all. Hold on. They just both updated to 496.6 tonight. 498.4, 498.6, and they both changed to 496.6, which is wrong. Futz with the power, it'll definitely work. $498.6. They're both 496.6, dude. Why? Oh, even that. Oh, I just didn't wire it out far enough. Lol. Okay, that worked. Problem solved. This is one of those times when I don't question it. So, one thing that might help you do things with variables is keyframes. Use a keyframe to change a modifier to plus, minus, set, get. Huh. Right. Because keyframes can actually change properties of things that you otherwise wouldn't be able to change the properties of by a wire passing in. Right. I hadn't considered that. That's interesting. I don't know that that would help me in this case. But that's really good to keep in mind. Also, I suppose I could just do like a timeline on that. Actually, a timer would probably be even more reasonable on that. Maybe I should get rid of this, well, whatever. It's working and I'm not going to question it. Because what this hopefully does now is it spawns one rock, step to the next segment. It spawns the next rock, step to the next rock. Damn it. Yeah, well that's just because I used the wrong index. So, do we care about this being... We do. Wrong index. This is the segment index. Whereas this is the rock index. Oh, why though? That didn't work, right? No, that was all wrong. This was mostly right. I think this is just wired up to the wrong thing. Step to the next thing. Oh my god, no, that's it. That isn't right. That isn't right. What gives? Okay, so here's the thing. Let's see. If this equals 0, then next segment. Oh my god, why am I having so much trouble with what is just a couple loops tonight? So, what do these two different things do? This is supposed to be telling us whether we go to the next segment or to the next rock in the segment. And that's because, yeah, sure enough, that's the correct thing for that initial logic. But then for lerping, I'm supposed to use this, which would then why is this wrong? Sorry, lerping is linear interpolation. So essentially, like, if you have something at point A and something at point B, then if you lerp between A and B with a value of 0.5, it will be halfway between. If you lerp with a value of 0.25, it'll be a quarter of the way from A to B. So by changing your sort of t parameter, it's called, from 0 to 1, you just sort of linearly blend between A and B. It's a really common operation. The formula, I mean, you can see it right here. I pulled this off the Dreamiverse, but it's whatever. It's basically just 1 minus t times b. Oh, they actually have done some math on this. Whatever. They've like shuffled it into a different form. But in any case, what I'm trying to do is, like, you see that I have these sort of zigzag paths that I need to fill out on a grid. What I need to do is, like, I have just the corners, and so I need to calculate how many steps I need to do in between each corner. And so if I have a segment of length 4 and I've already placed the bottom one, I mean, there's going to be 5 rocks total. You know, if I'm going from coordinate 0 to coordinate 4, that's 0, 1, 2, 3, 4, 5 items. But if I've spawned thing 0, then I have 4 more to spawn. 1, 2, 3, 4. And so if I know that I have 4 things total to spawn and my index starts at 1, then I would go 1 over 4 is 0.25, quarter of the way. 2 over 4 is 0.5, half of the way. 3 over 4, 0.75, 3/4 of the way. And then 4 over 4, the whole way. And that spawns all 4 rocks in all 4 correct places. And I'm somehow calculating these indexes wrong, which is hilarious. So there's 2 coming in here. Obviously there's... So that's 0. Why that's spawning all the way down here, I don't know. Am I lerping wrong? I am. That's my problem. What is this, like, janked up electro swing? Okay, so now my problem is simply that I need to like add 1 to yonder rock index. Seriously, what is this jank? What is this? So, rock starts there, then we step to the next segment. Yep, then we get a rock there, and a rock there. That's the end of that segment. Step to the next segment. Get a rock there, and a rock there. Oh, thank goodness. There we go. And then we can step to the next one, which should have spawned a rock. Where would that have spawned a rock? I don't know if we're spawning rocks correctly yet. Nope, screwed it up. Because this also should have reset this iterator. So let's see what's happening here again. So spawn that one, step to the next. Spawn those, step to the next. Spawn those, now we're done with that. But then we step that iterator, and now, yep, sure enough, we're spawning one there. And then next. That was it. Next. Woo! Yay, look at that. We created the shape from the picture on the left here. Okay. Progress is made. They're a little bit closer together than perhaps I would like. But let's go ahead now and let's try to set up the sort of automatic timing of spawning all this stuff rather than manually punching switches. So basically we're going to need stuff to step around from one to the next. Also, this is gonna have to like output a thing for done because there's a frame delay on it. I don't want to forget to do this. This thing is unconditionally without a frame delay going to set stuff to done. The other one, because of the frame delay, is going to be a little bit stranger. Because this one is basically going to be on this output done. So let's throw an AND gate on this that represents when all these things are done, basically. For the most part, it's actually not really that crazy. Oh, this isn't quite right. Actually, we don't have to do anything with that. Because I'm pretty sure it's just when... Well, let's see. I set these up, and I guess I should just start using them. Next segment wireless receiver goes here. Why you gotta be like that? You gotta be like that. Ugh. The other one is next rock. Now apparently my logic for when to fire those needs to be a little bit different. Figures. I mean, if I were to do this, then we would get the same flickering issue back, which I'm not a fan of. Grief. I wish that this stuff was off to start, because I think it's actually more or less correct having these things in here. Except for this horrible flicker. Which I guess sort of basically means that if I put all of this in like an init delay, then we might be okay, you know? In fact, I can test that out by wiring another switch into here. This worked for me yesterday. Because now we're flickering, but I can power the whole thing down. So when I start it up, we're currently sort of trying to go, but then we'll wait. Okay, so that ticked through those like as fast as possible. I guess the alternative, which would be completely reasonable, that would get rid of the flickering, would be to put timers on this. Because timers, first of all, give me a nice means by which to control how this stuff flows, and also they don't run when the program's not running. So if we reset, let's see, we'll reset and power the timer, and then when it's done, then we'll fire that. We'll do the same down here. Now, why did next rock? So it's because the done on this segment should also kick us to the next segment. I'm not sure why we went an extra tick there, but that's fine. Yeah, because now we're out of segments. When this thing goes done, then we need to go to the next path. So we've got next rock, next segment, and next path that all are going to be in play. Very glad to whoever it was who told me that a wireless transmitter is always a frame delay. That is very reassuring. It's just a comforting thing to know. You know? Boy, what an absolute pile this is. Okay, that's nice. That's nice. Yay! Now I can get started with the actual problem. Simulating sand falling through this whole thing. Oh, also, I'm sort of curious. I was going to make a random rotation. Let's see. Just for some visual variety. Because basically, yeah, if we want to make a transform, then we want to input a rotation. And if we want to input a rotation, then we can do Euler angles so that I can input some random yaw. Does this just do position, or does this, there's really no need for this to be its own microchip anymore, is there? It is a full transform. I'm just passing in a position right now. But we can do better. We'll see if this does better. I'm not convinced it'll do better. I wanted to try some random yaw. Basically just a random... what am I doing? I wish that I could, like... Well, whatever. We're going to activate one of 4 ports that's each going to have... Let's see, does this take... Does it take degrees? I'm gonna hope it takes degrees. I guess 0 is fine for one of them. Then one should be 90. $180 and $270. Why? Yeah, that's a little more visually pleasing. I might just shrink the rock down slightly, I guess. Oh, interesting. I guess I have to do that on the emitter. Also, I'm absolutely just moving. So useless. That's nice. Just a little visual variety there. I guess I could also theoretically do the same for the other dimensions, but these rocks are not completely... Well, I guess if it works in those other directions, maybe it would work. Like... Yeah. Alright, well I'm persuaded that I should make a random angle increments of 90 degrees thing. Just makes it very visually pleasing. You understand. Yeah, that's nice, actually. This looks a little more interesting. It's not perfect, but it doesn't have to be. It's weird that one of them seems to, like, it's spawning an extra one in the end there. Why it's doing that is unclear to me. But it should be fine. Let me check one thing before I move on, which is to make sure that these are still pretty much on the grid, kind of no matter where. They look pretty gridular. I don't know, should be good enough. As long as they're mostly in the grid, then I'm fine. Huh. Well, I don't know why we're spawning one extra, but it doesn't matter. So. Let's see. Oh, this is different from the usual lo-fi. Once I've spawned all that, let's see, I should really try to like bundle this up as like, I'm gonna put literally all of this on one big frickin' microchip. Which is just spawn the world. Because when that's done, I want to move on with other important stuff in the program. So. Let's see, I guess I need a node for the origin. Okay, this song is actually kind of annoying. Are we done yet? We are not even close to done. All right. We're going to have a done, speaking of being done, we're going to have this whole thing out here that reports when we're done with just all the everything. Which will allow us to move on to the next phase of our master plan. I guess I'll grab a selector so that we can kind of sequence through all this. I'm gonna take my chances and make a cycle. So far so good. So now when that's all done, we can start simulating sand coming down. The sand is going to be, I mean, I should probably just do like a square that looks sandy, and that will be sufficient. Let's go back into sculpt mode for me. I need to make, I think this is already the correct size. It's more or less what you're seeing for that there. So that's it. This is sand. Let's go into some styling and stuff though. I definitely, if I want it to look really, well, first of all, it's going to be extremely loose because it's sand. The fleck type, I suppose, will be something that seems okay. It should be highly ruffled. Not even a little bit neat. And I don't think we want any combing. Is that all there is to it? Just make it a lighter, sandier color and that's it. I don't know about the triangles, but I'm not sure what else would look good. That actually looks a little better, I think. Ooh. We may be getting somewhere now. Ooh. That'll do. Should obviously be extremely rough. Can't imagine why we would want it to be anything else. Yeah, that makes sense. Sand is not known for being shiny. As for the colors, it should probably be a real light brown. I guess that's what that looks like in this light. That's fine. Well, to be honest, I kind of want it to be a little bit redder. Redder tinged. This is better. Maybe I'll just slightly... Yeah, whatever. So that's a sand, in case you couldn't tell. Uno Sando. So... I guess what that means is I need to get the whole process going up here. I guess, let's see. Let me make a new microchip so that we like don't activate any of this until the time is right. Although it'll be annoying. Turn off grid. Grid snap bad. So what we're gonna do is start spawning sand that is then going to tick through a simulation. And I think what we can do is just have sort of a... Well, let's start... We know we need an emitter. We'll start with that. We're going to emit sand with a... Only once, when powered on, no maximum. We will tell you where. When we do that, so let's see, the sand though is going to have a microchip on it, and this is going to be actually, I think, where much of the rest of the program lives. So when we spawn one of these, it's going to have its own sort of falling behavior, where I think we can basically just do a timer that, like, you know, we'll do like 1 second at a time for now, and we can speed this up. When it's done, it can reset. We'll do that shenanigan again. Shenanigan again. And then we will set up the logic for it to actually, like, step. We want this thing to have variables that are like initialized. They start out at a certain value, which I think should be pretty easy. We know that sand spawns at 500 0. That is just the place the sand starts. We'll call this X and the other one Y. And we'll just have these around. I had all the buttons wrong. 500 0. We'll combine those into a 2-wire just because we can. We are also, though, going to need this stuff. Same as over here. And we need to make sure to spawn with wires so that we don't lose that. Okay. the way they calculate coordinates is dependent on a tag actually present in the world, so they need to be hooked up to that. Shouldn't be an issue. Oh, the reason that I was thinking about that is because I know that I'm going to need this again. The same two-world coordinate thinger that tells us where we are, or are supposed to be, I guess. What I'm gonna do with this is set up a mover follower thingy. Follower. And we'll mess with the exact specifics of this later, but basically, yeah, if we're spawning sand, which apparently, like, why did we spawn one already? Oh. This is fine. It's just, why? You gotta be like that. So. That damping is pretty stupid. Okay, that'll do. It'll make more sense once we spawn, but that's where it's going to start. And now we're going to start this logic of ticking it one step at a time. It's going to do so with wireless transmitters. Let's see, this I need to set it up as rock. Because I need to set up wireless transmitters that detect tags. I guess I also need... Here's the thing. It really doesn't need to be called rock. It should just be called thing. If you detect a thing, really I guess an obstacle, if we want to be really kind of obvious about it. Because sand and rocks are both obstacles for falling sand. Okay, that's just beautiful. Okay, there we go. So this, you two are an obstacle. Let's set up the wireless, or I guess just trigger zones. Since we're detecting tags, not actually sending values around. First of all, make sure you're centered within this, then we know that the zone size should be, I think, just 0.5. Yeah. And then just scoot it. So this is down. We are going to have similar for down left, down right. This, I think, is going to be really fun. We're basically building cellular automata with stuff in dreams, which should be very, very pleasant. Down left, we'll scoot over to here. Down right, we'll scoot over to here. That should be all I need for grid snap right now. So what I can do now is set up kind of my logical sequence of seeing if we detected the thing, and all of these should be set up correctly for that. They need one thing, and they're detecting tags, so... If this happens, then we're going to... Well, this is where, like, basically on timer tick, we're going to do this logic. So what's going to happen here, I think, is if this thing is true, then we're going to move down. So we're going to have variable modifiers that, you know, sets of variable modifiers that we're going to be powering. So we'll put those on microchips just to be nice to ourselves. So this is going to modify only here the x variable. We're going to add 0. I'm just going to include both x and y on these things just because I can. When we're moving down, that means we're going to add 1 because this grid goes top down. So that's going to be what that one does. I have to set up a little bit of a weird logical sequence that I did last time, which is basically, well, it's a lot of NOT gates. You know, you just know how it goes. Where if this is not true, then... See, I need microchips for these too, because the power situation is about to get stupid. Don't rotate. How you do that? If this is not the case, then, you know, we're going to have like another microchip for this and why this it's not gate. But the reason for the microchips here is because NOT gates get weird when you're doing this kind of sequence where you want to just be like logically enabling and disabling chunks, because what'll happen is if I have 3 things in a row, then like this one would be outputting true, and the NOT would be outputting false. So the next thing down would be powered off. But then if I had that wired into a NOT gate, that's powered off. So then that NOT gate powers on, and then that activates this one down here. They like alternate. So I need to sort of keep the logic of things that I want to be active, and also what do you do if they're not active, contained in this way. So let's set this up. This is moving now down and to the left if we can. So that would be like x gets a -1 in addition to the y getting a 1 as usual. And this is x gets +1. Trying to move down to the right. And if that's not the case, then we're going to send out a signal. For sand done. Stupid, over huge microchips. They gotta be like that. Okay, I'm a little confused why this one seemingly isn't doing anything. The timer should be ticking, which means that it should be updating its sand done, huh? Yeah, my logic's all wrong. The logic, it is all wrong. It is backwards. If there is thing below you, move into it. Else, stay where you are. That's exactly what I wanted. So, time to flip some of these guys around. No, that is right. Okay. I thought this was looping around like this. I was feeling so good. My hubris. Oh, screw you. It actually isn't detecting these tags, is it? Because that actually depends on where the tag itself is visually placed. Is that true? Is that true? I don't think that's true. I don't know about this. flies through. Well, this is not working how I wanted it to work. Let me actually... Yeah, why? Why you no detect? Why no detecto? Let's just get one block working without any emitter shenanigans. It is currently detecting. I'm gonna change the logic around on this slightly, which is to have a NOT gate on this so that we still get the like flicker pulse of okay, now activate X, but okay, so the logic is actually working, but when we're done, we need to actually disable stuff. Somehow. It just wants to fly down there. And why? Why, I say. Why? These are just when powered on. I have no explanation for that. But when we get there, I think we basically just need a selector on board that we can toggle over to Dunzo. It can keep ticking down if it wants to, but why did it like scoot? It did a little scoot. Why did it do that? Well, it's whatever. This isn't quite what I want because well, really, I think I just want to pulse this. Just because I don't want to be continuously sending sand done. So we should have gotten a flicker of sand done. And we did. So that seems to be one thing. Moving pretty good. If we set up, we just manually set up another what? Why are you moving like that? What? These are both setting here, but here is no good because I did not scope correctly. Yeah. Huh? What? Stop! Why would you do that? What is happening? You have the exact same instructions as anything else, and this is what you choose to do? Why? This is not detecting anything. Why are you moving continuously? Why? I actually understand it, like... Oh, the problem is that its coordinates are exactly the same still as the other block. Starting it up higher doesn't mean anything. It's got coordinates that it is trying to visit. Which means that I guess what I should do is set, like, some sort of timer. Just to be like, 5 seconds later, you can run. So that we have time to watch this one go. Yeah, a little bit jank. That sucks. It went to the right place, but it looked bad doing it. I don't really understand why these are clearly not aligned on the same grid. Clearly not aligned on the same grid. Okay, but actually, why would I need to power off this thing? Like, what? I guess it's because it's like flickering through some other states here. Okay, so I'm going to go back to just this. Why does it keep going? It should have ticked into the done state and stopped the timer. Come on, man. Come on, what? What? Come on. There's no way. That doesn't make any sense. Come on. When we are in this state right here, we should see a thing below us, and we do. We should see a thing to the bottom left of us, and we do. We should see a thing to the bottom right of us, and we do. Do trigger zones have a frame delay? They must have a frame delay. It's asinine. So those have to remain powered all the time, presumably. This is stupid, but I will live. The power is now all wrong because each of these needs to be like an input node. For whether we detected a thing, and an output node. Yeah. So these are going to be our little building blocks. Each of these gets one of these wired in. This powers this. 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 This triggers this. There we are. Cool. So trigger zones have a frame delay. They do not activate the first frame they are powered on. For shame, to be honest. That's kind of terrible behavior. That's kind of the worst. Not a fan. Learn something new every day. Okay. So now we could do our little... I got rid of my timer. It's fine. What we can do is... start spawning sand for real in this program. Set up a wireless receiver for sand done, and to be honest, we'll be very close to done with this problem. Oh, I suppose I should have it actually emit sand. Also, it needs to emit it at the correct place. So many important little details. So, 1 We're going to grab our coordinates again, but we're going to manually feed in some coordinates this time. I'll just grab these. I guess there's really no need to grab the splitter. It's not useful to me. They spawn though at 500, 0. Those are the world coordinates where these things spawn. We will combine these into A2. Pass that into our combiner here along with our origin, and then that goes into the emitter on scene space transform. So after it spawns everything and ticks over to this, then I will forget to activate this, and then, you know. Interesting. It's like actually not doing the one pulse of this that it was supposed to. You know, because like it sure looked to me like it would spawn one, but it didn't. Lame. Lame. So what I think we're gonna do is set up a stupid frame delay. Big stupid. We're gonna send another sand done signal. Just a preemptive one sand is done signal. Which will definitely not interfere with my ability to count up the results of this program in the end. Definitely not. You gonna spawn more? You're supposed to spawn more. Figures. Well, why that's happening is not clear to me. It's not moving anymore. There. We saw the next one spawn. One's gonna move down and to the left. And then nothing's gonna fire. Why would it? So intriguingly, both of... I guess intriguingly it just never spawned... It never fired this at all. But surely it should have, right? I've got an idea. Let's move this up to the selector. Let's move this all down here. Where basically then right when we first enter this state we'll fire, but then there's no power shenanigans on that at all. We should always, always get a good pulse there as soon as we enter that final state. Yeah. Yay! The sand settles down just like it should. I gotta speed it way the heck up though. Way up. Otherwise this will take way too long. This is neat. Makes me happy. This makes me happy. How does this look in camera? This looks pretty good. I might start the sand up higher, like artificially higher, just because I can. So this is fun now. It should start like flowing off to the left. Or I guess it has to pile up to here, and now it'll flow off to the left all the way. I like it. Yep, and at that point the algorithm is done. Now, does that agree with the actual problem? Yep. It does. Correct answer. That's awesome. That's awesome. Okay. So yeah, let's speed it up. Damn it. I'm in the camera. Get me out of the camera. So it's sort of a two-part thing. I need to like speed up how fast it falls and speed up the timer and just sort of see how those combine. Because yeah, that's like better, but that's nice. It still like has just enough acceleration and deceleration to give you the idea of a cellular automaton, but it's like just smooth and oh, okay, so it is a little bit broken. All right, that was bound to happen. It's just a little aggressive. Phooey. As long as I still get the right answer, that's what matters. Yeah, there we go. And as soon as it starts falling into the void, then I actually want, I want to kind of, well, there's honestly something kind of fun that I want to do at that point. I should save this. This is working well, but basically, if my coordinates ever go to 10 or higher, I'm gonna say like above 10, just to be paranoid, then I need to send a new signal. That is that we are voiding out. Sand void. And when that happens over here, well, then we got to do something else. Also, let's see, I need to the first time that we enter state B here, we need to reset. Well, so what do we need? We need a num sands or something. The number of sand units that fall. We need to set that to 0 the first time that we enter this state. This is sort of a cheat, but we're gonna need to display that number pretty soon, so. Because from here on out, we also need to increment this. I don't know which of those is gonna win. We'll see which one wins. Yeah, that actually works well. Cool. Let's hook up that number displayer, shall we? It's gonna be in the scene somewhere. Where exactly remains to be seen. Is 24 the right answer? Yes. 24 is the right answer, which is very nice. Let's add some elves for scenery. That's a... Gosh, dang it. Oh, you want to be in slidey mode, huh? See, where would be another cool place for one of them elves to stand? Way back there. There. Oh, I was going to make it spawn the sand up off screen. Like way up off screen. Because basically, if I set the Y at like -6, say, why did that not take? Yeah, -6 should work fine. I just need... No! Damn it, I keep moving the camera. I love how the imp looks when they squash up against the bottom of the screen. I can maybe actually spawn it a little lower. Maybe -4. Let's try that. Yeah, that's nice. I guess the only thing I might change is like... Let me try, this is going to be a little bit interesting, but let's try scooting this over a few ticks. What does that frame up? I'm pleased to see that I set it up correctly to like respect the tag as the origin for everything. It just shifted all the sand over. I think that's pretty nice. Just frames up slightly better. And we'll show the sand disappearing into the void. The thing that I want to do, after we void out, is start spawning more frequently. Which is a little odd, but basically I think that when we receive sand void, then we want to start a recurring timer for how often we spawn these things. Maybe we can just reuse this selector. Or when we're in this state. I'm not going to use that selector. That's lame. All I want to do is this. I just want to start powering this timer, which is going to reset itself so that like every second it spawns a new what? A new one. Can't think, can't speak. So that upon reaching the void, then let's see, the number is going to be wrong here, but so be it. Kind of wonder if the sand could look a little looser. Does that look sandy enough? It looks pretty good. So the number is going to be wrong, but so be it. Gosh, would it be possible to speed it up at all? I should try speeding it up again. If I can just really crank up the follower speed, I can probably make this go pretty fast. But only 2 more are going to fall here, so. And then they're going to start spawning a lot more frequently. No, they're not. Why is this 4? I keep trying to type. Very nice, very nice. I should probably have them self-kill when their coordinates go above a certain level. So when your coordinates go above like 20, then we'll just Tack on the old destroyer. So you can pop out of existence. Okay. And yeah, let me see if I can speed this up. So I want this to go at like 0.2, but this is going to have issues because you can see it's kind of moving a little too smoothly. We'll just see if this stacks up well. If it does, then great. I thought that was the wrong thing for a second. I'm pretty sure it's not. But it made me nervous. This will be the real question. It's when it starts sliding off sideways over here. But it seems to work well. Oh, I nailed it. They're all in here somewhere, fizzling out of existence. But who knows where? Who can say? Well, great. That's very good. Awesome. Yeah, I'm really pleased with how this looks. I guess, like I said, the one thing maybe is just to loosen this up a little. We're getting real nuance now. I guess also, maybe it would look good with a little bit of animation on the yeah, it just gets way too fuzzy looking. I think it looks better like that. That said, maybe some kind of effect. It looks a little bit shifty. Just a little bit of all the effects, you know? Yeah, it looks nice. Just a little bit of motion. Although it's weird and kind of bad that they all have exactly the same animation going. It's like, can I ask that they're not all literally identical in their whole rippling pattern? That's kind of obnoxious. Just now it actually looks more monotonous. Didn't mean to rotate it. I really never mean to rotate it. And yet rotating it is what I get. I'm making a microchip here that will just give me a random cardinal direction rotation. Just random 90-degree rotato. Which I think I can just use then. Stop rotating. Why are you doing this? You know, sure, let's just do all my code like this. This is what I want. You know, put it up over here. You know? Let's see here. I wanted to emit with not merely a position, but also a rotation. Boy, I can just like add on to this and achieve that quite easily. Isn't that nice? Who's making this lo-fi that like lazy sampling weirdness? That'll be the transform. This is the position. This is the rotation, you know. It's beautiful. Give it a little more space up here, you know. Perfect, perfect. Shrink that back down. Right. The wireless transmitters are now just pointing in other directions. That was fun. We did have fun. This is sufficient. It looks a little bit visually monotonous, but oh well. You know, doesn't matter. To do anything differently would, excuse me, be a little bit more annoying. So I just won't bother. I would have to like reach into the group to rotate the thing, or I'd have to like rotate it on spawn, and I just don't want to think about that. I like doing this kind of thing in Dreams. So like, this is the first sort of cellular automata that I've made. If you're unfamiliar with the term, it's basically a thing where like you have a bunch of cells in a grid, and then each cell has rules about how it updates. And Conway's Game of Life is an example of this, where like, you know, you have a grid, and then if you start with a single thing, you know, a single square, then like each square has rules about like, depending on its adjacent squares, it will either live or die, or it will sort of like spawn things next to it or itself die. There's just like a couple simple rules, and then it can just sort of like play on from there on its own. And in Dreams, you can do this by just like setting up a grid of things that can, I guess, as long as things can spawn and things can move and things can die, like you can kind of just set up these nice little cellular simulations that are kind of pleasant, and they all just sort of happen concurrently by magic, which is fun. So this is great. This is my solution for the day. Here, I want to save it in when it's like partway filled up. I think that'll make for a better thumbnail. I can't believe the quality of this scene that somebody made too. Like, it just looks so good. Let's save this. We'll release it. It's public. That is that. It is done. We got 24, just like we wanted to. All right. This is very nice. Let's, because I have just a smidge more time, let me look at the actual Advent of Code puzzle input. Yeah, I'm not doing this. I was a little curious, but this is the number of rocky paths that I would have to handle. Plus the whole thing would be like enormous compared to the size of the cave here. So that's not going to happen. However, one thing that might be fun to do, just to sort of like prove that this is working and that it's not just like totally hard-coded, is to go in and change sort of the starter program that we spawn with. So to bring back some of the early stuff. So the numbers down here, I will, there we go. The numbers down here determine the structure that we make on the grid. And we can easily mess with that to like change where the paths go, or draw new ones or whatever. So like one fun one, let me make it so that it goes, if it goes from 498.4 down to 498.6, and then it went to 496.6, but let's have it go to 501.6. And let's just watch that one go. Oh, that's so nice. So now it'll fill that up, and then it'll flow off and sort of fill the other thing up a little bit. This is one of my favorite days I've done yet. This is just so nice. Oh yeah, that could be an interesting application. Yeah, actually, that would be wild to try to set up like an RNG modular dungeon sort of system in Dreams. If you could have things just sort of spawn and move into position, the whole dungeon assembles and then populates with monsters, and then you fight through it. That would be pretty cool. That would be cool. Let's make this actually a little bit longer still by extending this path. I'm not going to save any of this because I want it to replicate the example pretty cleanly. But let's make this now go, it's at 494.9, but let's make it now go to like 494.7. So we're going to make sort of an extra little lip. Ah, I love that I can like actually see. This is Like, so many nights I'm just like, get it working, quit. The fact that it's not midnight, it's not 2 a.m. yet, means that I can actually, like, I have a little bit of mental bandwidth to play around with this. And boy, do I like being able to just, like, reach in, change some early parameters, the whole rest of the program flows from it. Feels so nice. Yeah, so this is going to fill up that little bit and then eventually overflow the lip. Oh, this is going to pile up a whole extra layer. And now everything starts sliding off. 30 sand pieces. And there they all go. Ah, man, that's awesome. See, this is like the best case scenario for doing these problems in dreams. Because if I'm doing this just in a normal programming language, then at the end, I have the right answer, and it looks like, you know, at best, a grid of text characters like you see over there. But in dreams, I get this. You know, it definitely takes some extra time, and who knows, maybe aspects of that could be sped up, but I mean, come on, man. It looks awesome. I can, like, I really enjoy, see, there's definitely some extra, whoa, I got something in my eye. There's definitely some extra work imposed by sort of visualizing it as you build it and visualizing it in a, like, semi-production ready way. But I like the end result. I really do. And it's kind of, aside from just the usual, like, frame delay sorts of problems that are so infuriating, having something like this, I really do kind of like solving problems this way. Like, you know, for me, the ideal case would be, like, writing chunks of, like, each node, like, I could be writing those nodes in a different programming language. Like, I can just type out, this is what this node does, right? And I can do loops, I can do all this internal stuff, it can be whatever. But then it can just act as a node and, you know, sequence in the rest of this whole thing so that I can hook it up with, like, okay, now do this once you're in this position and once you're in this position and that kind of thing. That for me would be the ideal. Because all my issues, I think, with programming in dreams here, it's, like, locally more difficult. It takes way longer to make math expressions. It takes way longer to set up, like, loops and complex computations. Because that's not what it's built for. What it's good at is all of this connecting this to this, move to here, move to there, start a timer, end a timer, just, you know, the scripting part of it, which obviously it's what it's designed for. But, like, it's good at that, man. All right. I'm gonna call it there for the evening. For once, I'm going to actually get some sleep, play some games. Who knows? I got all the time in the world. Let me see if anybody I know is streaming who could. Literally nobody. All right, whatever. Thanks all for hanging out. I feel good about this, and I will see you again tomorrow for the day. What's it gonna be? Day 15? Oh, before I go, I should add this to my collection here. Two weeks! Done! 2 full weeks of problems. All right. All right. See you tomorrow. Great stream today. Thanks for hanging out. Goodbye.